So just like we talked about when you like throw something up in the air and it comes back down, what you'll find with parabolas is that if you want to figure out a maximum or a minimum, you're going to end up just finding the vertex. Because if I were to throw a ball in the air and it creates this parabola and it comes back down, the highest point that that ball would have gone would be my vertex. So the maximum height of the ball that was thrown would be happening at the vertex, okay? And so if you have a parabola that's pointing down, let's say we want to minimize something, then you're going to find, again, you're looking for your vertex because the minimum point is going to happen if the parabola is pointing up. And so anytime you see the terms maximize or minimize, and it's a parabola or quadratic formula that you have there, you are definitely just looking for that vertex. Those are the only places you're going to see a max or min happen for something that is a parabola. So this particular question says, Phillips plans to construct a dog pen off the back of his garage using its back wall as one side of the pen, and constructing the rest of the rectangular pen from 28 feet of fencing. Determine the maximum area of the pen and its dimensions. So anytime you have a problem like this, you want to sketch a little picture. What are we talking about here? Well, he has a wall, and he wants to enclose 3 sides of that wall to make this rectangular pen, all right? Because the wall itself is going to be one of the sides. We know how much fencing he has. So perimeter would normally include all 4 sides of a rectangle, but we don't need any fencing right here. We have a wall. And so the perimeter is going to be these 3 sides. So if this left side is X, this side is X. We know how much fencing he has. So if I have X amount of fencing here and X amount of fencing here, then I have the total 28 feet of fencing minus 2X, whatever I've already used on the sides. Okay, so I could have done it the other way. I could have said Y and Y and 28 minus 2Y, but typically your variable there that you plug in is going to be an X. So 28 fencing 28 feet. We used up X's here. So this dimension here is going to be 28, what I've already used. Now they're actually wanting us to figure out area. Well, how do I solve for area? Well, area is going to be one side times the other. Length times width. That's a rectangle for area. And so if I did this length times width to find my area, I would say it would look something like this. One dimension times the other. All right, if you distribute that, you're going to get the area as 28x minus 2x squared. All right, this is a quadratic. We have an x squared. All right, and so I am going to put this so it actually looks like a quadratic. And you can see that I have negative 2x squared plus 28. Well, if they are asking for the maximum area here, then I am going to have to figure out what the vertex of this is. This is a quadratic. The maximum should happen at the vertex. All right. Now my pen is a rectangle, right? But the area options are going to create my dimension options are going to create a parabola because it's a quadratic here. So I'm just going to say, how do I find the vertex? Well, negative b over 2a and then plug it in. And so if I do negative b over 2a, my b is 28 here, negative b over my 2 times a, which is negative 2, right? And I get negative 28 over negative 4. That's a nice and easy division. So 7. Well, what did I solve for? Well, I solved for x, right? What does x represent? Well, in my drawing, x represents this and this. So I used up 7 feet here and 7 feet here. Well, how do I find my other dimension? Just plug it in, right? 28 minus 2 times 7. What's my other dimension here? Should be what? 14, right? So 28 minus 14, that should be 14. It says, what are your dimensions? Well, my dimensions are going to be 7 feet by 14 feet, right? And I should be able to then calculate my area. How do I calculate my area? Well, 7 times 14. My area here is going to be 98 feet squared. All right? And so when they give you something like this, you're going to sketch it if it's something that you can sketch, and then you're going to calculate. Anytime they see the word maximum or minimum, they're really asking for the vertex. Asking for the vertex here. This is a flight between two cities, averages 81 passengers when the airline charges $210. The airline estimates that it will lose one passenger for every $3 fare increase. What is the maximum revenue generated by this flight, and how much should the airline charge to achieve the maximum revenue? All right. So for every $3 increase, they're going to lose a passenger. So we are going to say that X is going to equal the number of $3 increases. For every. When you see that for every, that's probably where your variable is going to be. All right. Now the price is going to do this. The price is going to start at 210. All right, so the price is going to look like this. Right now it's $210. And we will add to it $3 for every increase. Right? So if they increase it once, we're going to add $3. If they increase it twice, we'd add $6. All right. Passengers. Well, passengers is going to go down. So the number of passengers then will go down. It will start at 81, but we will lose one passenger for every $3 increase. All right. Well, how do we calculate how much they make? Well, the number of passengers times the amount that they charge, right? That's how we calculate their gross revenue. So if I were to do that, I would say, well, that's going to be how much we charge times my increase there. All right, times my increase. All right, this guy's going to be huge, by the way. So we have 81 times. When you calculate this all out, you actually get it out of order. So you get 210 times 81. This is why we have a calculator, so don't want to spend all day here. You get negative 210 and positive 843 or something. And so you're going to end up with a 33x here in the center. And then, of course, you get the negative 3x squared. So all I did was FOIL it, right? So first, outer, inner, last, right? And you get your quadratic. I always rewrite it to standard form. So I have negative 3x squared, positive 33x, and positive 17010. Always rewrite it to standard form. All right. If we're asking the maximum revenue, maximum means I'm going to find the vertex. You're going to find the vertex the way you always would. You're going to do negative b. So we're going to say negative 33 over 2 times a, which is negative 3. All right. It actually ends up being a decimal. So you end up 33 divided by 6, right? Which gives you 5.5. 5.5. All right, 5.5 gave us our x value of our vertex. So 5.5 is the x value of the vertex, right? Remember when we find our axis, that actually also gives us the x value of the vertex, all right? It's important because you have to know what we're talking about here. What did I say my x was? The number of increases, okay? The number of increases, all right? Does that make sense? So I'm looking for the number of increases here. It is 5.5. If I want to know what my revenue is going to be at 5.5, then I have to plug it into this guy, right? Because that actually told me my revenue, the number of passengers times what I'm charging. All right. You can either plug it into this or you can plug it into there, the 5.5. It doesn't matter wherever you plug it in. You're probably going to use a calculator to do it. But when you plug in your 5.5, that gives you the Y value. That's your revenue. All right. And so your revenue ends up being something like 226.5, right? You can also come up here and just figure out what you charge and your passengers and multiply the two. So you could do it individually. You could say, what's my new price? 226. What's my revenue? My revenue is a big old number, 17. So I could take that 226 if I calculated it and multiply it by how many passengers, and I would get the total amount I'm going to make. So my ticket price is 226. If I multiply it by 81 minus 5.5, which is not possible, but we'll round it, then you would get that. In a word problem, I would probably actually round that down. You're not going to lose 5.5 passengers, or we have another issue with the airplane. So you can either round it up to 6 passengers, right? You just need to tell me if you do. So if you're talking about people and you get a half, I would completely understand if you rounded. So again, we have a selling price currently at 150. And we are selling, so this is my price, and these are my customers or my units. So if I have a certain number of units, I sell 100 currently. The sales are expected to increase by 5 juicers for each $5. So if X equals my $5, my number of $5 increases, then I would say units are going to go up. I'm going to sell 5 more for every $5, but my price is going to go down $5 for every $5. I will say what I did here is I divided a 5 out of everything because I can. If you have a common factor out of the whole thing, because if I take the number of units that I have times the price, you're going to see a common factor, and you can actually pull that guy out in front and it will work. So I actually did mine by going 20 plus X and 30 minus X, just to make my numbers smaller. So it works the same when you have a common factor in all of it. And so you end up, when you FOIL that thing, you get negative X squared plus 10X plus 600. All right. So if you figure out how many $5 increase, it's going to be B over 2 times A, which gives me 5. I should have 5 $5 increases. So if they say what price would that generate, well, I'm just going to plug that in. So my price is going to be 150 minus 5 $5 increases. It's going to be 150 minus 25. My price is going to go to 125. All right. My number of sales is going to go 100 plus 5 times that number of increases that I did. So my sales are actually going to go up to 125. If I try to figure out what I made, well, I'm going to take what I'm selling it for by how many I sold, and I'm going to get how much I made. All right. All right. Sometimes you're given a lot of different information from data, and you're going to put it on what's called a scatter plot. And you can look at the scatter plot and say, hey, it's going to be a quadratic or it's going to be linear, and you can try to figure out what's the best type of equation to set up for it. So if you see a scatter plot like this, that looks like a parabola. If you see one like this, that looks more linear. This one doesn't look like anything. This one potentially could be part of a parabola. It depends on how, maybe you need more information to make sure that that's what's forming there. And so when you're trying to decide what's the best way to set these up, you're going to look at what is the image starting to form. If I can draw something in it, so this looks like a parabola, that I could draw an estimation with a linear. If I had more information, I could potentially do a parabola there, but this one doesn't really fit either. All right, and so sometimes you're going to see a lot of information given to you, and if you draw a scatter plot, it will tell you whether it's going to be linear maybe or whether it's going to be. Just like with finding equations of lines, sometimes you don't have the actual equation itself, you have other information. And so you can use your standard equations to then generate the rest of it. This says write the general form of an equation or just the standard form of equation. And they've given us that it goes through a specific point and it has a specific vertex. All right. So if I have the vertex, I'm actually going to start with my vertex form. So I'm going to say ax minus h squared plus k. I'm going to do that. If they gave me the vertex, they gave me the h and the k, and they gave me an x and a y. All right. So the only thing I don't have is really my a. And so I can plug in my x, my y, and my h, and my k, and I can solve for the a and figure out what my form should be. And so I'm going to do that. I'm going to plug it in. I'm going to say, well, -3 equals, I do not know what a is. I know what x is. H is 4. K is 6. And then I'm just going to do basic equation solving here. Subtract my 6 over. I'll get a -9. -2 plus 4 is going to give me, or -2 minus 4 rather, is going to give me -6. And if I square it, that's going to give me a 36. Divide both sides by that 36. 9 over 36 equals a. Reduce it, I'm going to get an a of -1/4. They want the standard form. Standard form is this form here. All right. So I figured out the a, which means I can write it in the vertex form. So I'm going to say y equals my a, x minus my h squared plus my k. If I want to get that into standard form, I'm just going to FOIL it and distribute and simplify, okay? So if I want to go from vertex form to standard form, this is vertex form, so we've already got one form of the equation. But if they want it in standard form, you need to FOIL and distribute. So if I FOIL this, remember, I'm just going to say x minus 4, x minus 4. So I'm going to get x squared minus 8x plus 16 when you FOIL that all out. And I still have that plus 6. I'm going to distribute through. And they were nice and gave me a 4. So -1/4 x squared. -1/4 times -8. That's going to give me a +2. Just 8 divided by 4. +16 divided by -4 is going to give me a -4. And I still have a plus 6. What can I do with the -4 and the plus 6? Yeah, I can combine those. So standard form, while this is vertex, standard is going to be -1/4 x squared plus 2x plus 2. And so given 2 points, you can actually also find it if one of those points is the vertex. If one of those points is the vertex, you can find it given those 2 points.